Our last topic then in Chapter 13 is looking at a special case called sexual selection, looking at the case where the process of mating, how males and females interact with a species, may have a direct impact on their evolution or which alleles are being passed on from one generation to the next. And in some species we see what we call sexual dimorphism. And sexual dimorphism just refers to when we have the male and the female of a species that physically look different or have different behaviors or different characteristics. And so di means two and morph means form. And so sexually two forms, a male form of the species and a female form of the species. Now obviously males and females are different. They have different sex organs or reproductive structures. But when we talk about sexual dimorphism, we're not referring to those sex organs, but instead we're referring to other characteristics which are sometimes referred to as secondary sex characteristics. And in some species, these are extremely exaggerated. In fact, for many species, males and females of the same species were actually classified as different species, as different organisms, and it wasn't until they were observed in nature mating that we realized that they were males and females of the same type of organism. Now, if we look kind of at a broad pattern, we see that sexual dimorphism is common throughout many different groups in the animal kingdom. A few types of insects have it, amphibians, especially if we think of frogs, see lots of frogs with sexual dimorphism, reptiles, especially the lizards, and then extremely common throughout the bird and the mammal orders. And so we see this very broad pattern of sexual dimorphism out there. If we look at a few examples from some different organisms, we do see a pretty common pattern here. For example, with the waterfowl and the birds, we see that the male there on the left is brightly colored and has very specific striping and coloration patterns, whereas the female is more camouflaged. With something like mammals and lions here, we see the male on the left has a large mane, whereas the female does not. Here with these Nalias, which is a type of antelope, we see on top the male has a mane similar to the lion's and has very large horns, whereas the female is more of a camouflage looking color there. Something like even fish. We see with salmon when they return back to their spawning grounds that the female there is on top, kind of maintain their sort of fishy shape, their aerodynamic shape, but males develop this really large hump in their back. And so our common pattern as we look across these different species is that the male has the unusual characteristic. Why would a male have a hump in its back, or a mane, or bright coloration? It makes sense that the female is aerodynamic in her shape in terms of the fish, or that the female is camouflaged. And so when we see a broad pattern like this across many different types of organisms, we know that there must be some sort of underlying cause that's the same for all these different species. Why are the males developing these unusual characteristics? And we've talked about natural selection quite a bit and how natural selection can cause evolution to occur. But if we think about it, if having a large beak is an advantage because the seeds are large and dry, then that's going to be the same for both males and females, and we would expect males and females both to develop large beaks if that were the case over time. And so natural selection, as we've described it so far, doesn't really account for how we can get differences between one sex and another. And so we look to what's called sexual selection, which is just a special case of natural selection, a special category. And in particular, if we think back to natural selection, we said natural selection was differential survival of a member of a population due to variation in one or more heritable traits, and in particular it was nature or the environment determining which traits were an advantage and which traits were a disadvantage. Well, in sexual selection, we're still going to have selection, so there's going to be variation in traits. Some variations are going to give organisms an advantage and some a disadvantage. But in sexual selection, it's not nature that's determining which traits are an advantage, but it's the process of mating that's going to determine which traits are an advantage. And so sexual selection is a differential fitness of individuals due to competitive mating or the process of acquiring a mate. And if we look at males and females, if males and females are developing different characteristics, that means certain characteristics are advantage for one sex but not the other, which means males and females must have different mating strategies in some of these species where we see sexual dimorphism, and those different strategies are going to relate then to different features. And so let's take a closer look at our sexual selection. And the real unifying theme here has to do with costs of reproduction. This is really at the heart of this issue of sexual selection. How much energy, how many nutrients, how expensive is it to produce offspring? And for females of most species, obviously reproduction is extremely expensive, taking a lot, again, of energy, nutrients, food, and so forth. And the main expense is parental care. In many species, the female provides all of the parental care. And sometimes I think maybe we lived in a little bit of a Disney-fied world where we kind of see the male and female chipmunks skipping down the pathway, raising their little baby chipmunks. The reality is, for most species, the female provides all of the parental care. And in fact, 90% of mammal species, our closest relatives, males have nothing to do with parental care, but females spend all the energy and nutrients raising the young. And as my wife was always quick to point out, even in the 10% of mammals where males do help raise the young, certainly females tend to spend a lot more energy than males do. And so because of that parental care expense, females have a tremendous cost of reproduction for most species. And since it's expensive for females to mate, if we think about female limits to reproduction, females typically are going to be limited by how many offspring or how many times they can mate that they can afford. Right? If each offspring is expensive, a female may only have enough energy or nutrients to be able to raise 3 offspring, or 10, or maybe 20, just depending on the particular species. But females are going to have a fixed limit. If females raise more offspring than they can afford, then that female's probably not going to survive, which in turn means her offspring probably aren't going to survive. And so what we start to see are behaviors where females are going to be very limited in how many offspring that they're going to produce because of the expense of each offspring. If we flip the coin over, though, and look at the male side of cost of reproduction, by comparison, obviously, it's going to be much cheaper to reproduce and have offspring. In particular, because there is very little or no parental care for most of these species for males. And so, again, it's going to be much reduced cost. And so if we think about males' limits to reproduction, males are not going to be limited by the same things that females are. Males aren't going to have a fixed limit in terms of how many offspring they can afford, because offspring are cheap. So males can have lots and lots of offspring. Okay. However, males aren't out there having a ton of offspring compared to females. The numbers are actually pretty similar. So males do have limits, but it's a different type of limit. For males, the limit is going to be finding a mate. How many mates can that male attract? How many females can that male convince he's the right choice to mate with? That's typically going to be our limiting factor for males. It's these cost of reproduction issues then between males and females are big differences that are going to directly relate then to different mating strategies when it comes time for choosing a mate. And so if we think of the female side of the coin, again, we said females are going to be limited by how many offspring they can physically afford to have. So the female strategy that we would expect during mating season is for females to exhibit choosy behavior. We wouldn't expect a female to mate with the first male that comes along, because if that male doesn't have very good genes, the female's offspring aren't going to survive, and she may not be able to have very many more. And that female then would not have very high fitness. She would not leave many alleles behind. But a female that has a choosy behavior, that's going to pick males with good genes that give her offspring the best chance to survive, that female is going to leave behind more copies of her genes as well. And so what we're going to see is females having a choosy behavior during mating season. And that's going to increase the fitness of those individuals. Now, I want to point out this is absolutely not a conscious decision. And sometimes it's easy to be anthropomorphic and kind of put our human emotions and conscious thought on things that aren't necessarily human and have those. It's not that females want to do this or that females do this consciously, but females that exhibit a choosy behavior are going to have higher fitness levels and pass on genes for that choosy behavior. So we're going to expect that choosy behavior to become more and more common. If we look at males, we would not expect to see choosy behavior because, again, males are not going to be limited by how many offspring they can have. So if a male mates with a female that doesn't have good genes and those offspring don't survive, it doesn't really cost the male anything. So males are going to have a different strategy. Male strategy is going to be to try to attract as many mates as possible. The more times a male mates, the more mates he can attract, the better his chance of leaving behind more copies of his genes. And so what we would expect to see then in males are any sort of traits that help males become attractive to females. Those are the types of traits we would expect to be more common in males versus in females. We would expect this choosy behavior to become more common. So not a physical but a behavioral trait. And again, these are not conscious decisions that I'm implying for these organisms, but organisms that have these behaviors or have these traits are going to have the highest fitness, and we're going to see those things become more common. There are two different types of sexual selection just depending on the interaction that's going on within a particular species. One type is intrasexual selection. And intra as a prefix means within, and so this is going to be an interaction within one particular species, and in this case it's going to be males interacting with males. And in species that show intrasexual selection, we see a lot of male-to-male combat, a lot of male-to-male very aggressive conflict and Typically, this is very ritualized. It's not going to be to the death, although certainly serious injuries or death could occur. But the idea in these species is during mating season, there's a very ritualistic sort of conflict that all the males will compete. And the male's success at mating and attracting females is going to be directly correlated with how did that male fare in the competition. The higher the male ranked in the competition, the better his chances of mating that mating season. And so the top males are going to mate with the most females. Males that are lower in the competition may not mate at all. In fact, many males may not mate, and they're going to have to wait another year till next mating season, where maybe they'll have grown bigger and stronger and then fare better in that competition. In some species, for example, if we look at some species of elk, the top male, the single male that wins the competition, mates with 80% of all the females in the population. The next male or two in line mates with the rest of the females, and the vast majority of males then aren't going to mate during the mating season. Now, if this is the case, what we would expect to see in our population over time is any trait that's going to help with the competition, that's going to help males succeed or win this conflict, are going to be more common in males. And not surprisingly, that's exactly what we see when we see these examples of intrasexual selection. Traits that give males a competitive advantage gradually become more common, and because these traits directly impact who reproduces and who doesn't, whose genes get passed on and whose don't, sometimes these traits can become very exaggerated very quickly. So for example, males that are larger or stronger are going to have a better chance in the competition. So we'll tend to see males very large in a species. If females are much smaller, that's an indication that we have intrasexual selection going on. Antlers and horns that help in these conflicts are also going to be some examples. And so for example, with deers, again, we see antlers or horns. Something like gorillas, males typically are about twice as large as adults as females are. And so a drastic difference between size, and that large male then is going to be dominant, and he's going to have a harem of females that he's going to mate with. If another male comes along, those two will compete with one another. The winner will take over the harem and, again, have more mates than the others. Now, we're not going to expect to see these traits, though, develop in females because there's a cost. The cost of being larger is it takes more food to grow larger. It takes more food to stay larger. And so for males, there's a benefit that outweighs the cost. The benefit is you can reproduce and pass on your genes. But in females, there's no benefit, so we're not going to expect to see that trait become more common in females. The second type of sexual selection is called intersexual selection, and inter as a prefix always means between, and so this is going to be an interaction between the sexes, between males and females of the species. And typically this is where we're going to see female mate choice play a big role, and males must convince females that they're the right choice when it comes time to mating season. So we're going to expect to see traits in males develop that are going to advertise the male's fitness, the males advertising to the females that they have the right genes, they're the right choice to mate with. And this may include physical features, like if we think of bright coloration patterns in birds, for example, or it may involve behavioral features like courtship behaviors or behaviors to show off, males showing off to females that they're the right choice. The most obvious of these physical features is bright coloration patterns. We think of something like a peacock, for example, and its bright coloration patterns. Again, we look at waterfowl like ducks. It's the male there on the left that's brightly colored versus the camouflage female. Something like this prairie chicken, we see the same thing. These really dramatic sort of coloration patterns, and males exhibit those. The more extreme their trait, the better their chance of mating. And the idea behind this is, well, why would a female choose a male that has a bright coloration pattern? Why would that be a benefit to the female? And again, it's not a conscious decision, but the idea is these coloration patterns serve as handicaps. If a male can survive, even though he's really easy to see, that male must have good genes. And so females that mate with those males, their offspring are going to have a better chance of surviving than if she were to mate with a different type of male. In addition to these coloration patterns, lots of really unusual or extreme behaviors going on here. Birds that sing songs, the male sings the song. If he sings it correctly, the female is going to choose him to mate with. If he doesn't, he's probably not going to get a mate. Territoriality, males that can identify which territory is going to provide optimum resources to raise those offspring, and then can defend that against other males. That's going to indicate to the female that that male has the right genes to be a good mating partner. Or lots of very specific courtship behaviors. And a lot of these courtship behaviors, again, can become very extreme, very intricate, and very odd, quite frankly, because they're going to determine directly who's passing on genes and who isn't. And a good example of that is a type of bird called a satin bower bird. So let's take a look at that example. And there are several different species of bowerbirds. They're native mostly to the Pacific Islands near Borneo, Australia and the Pacific Rim, that sort of region. And what we see with these bowerbirds is that the males aren't brightly colored, but they're going to build this bower. And a bower is a specialized nest that's used just for mating. It's not typically where they would nest, but they're going to build this during mating season. And if the male's doing this correctly, the female's gradually going to get closer and watch him build the bower, and eventually, if he does it correctly, she's going to mate with him. And so to build the bower, the male will clear a space on the forest floor, kind of remove all the leaves and dirt and sticks down to the soil, and then the male's going to get dried grass, sticks, twigs, anything long and skinny, and weave them together to kind of form two freestanding walls. Now, if he's done a good job to this point, the female's going to actually come and sit between these two walls while he finishes. And if he finishes up correctly, she's going to stay and mate with him. And of course, the way you finish a bower is you want to decorate it. Males will go out and collect anything with bright colors, whether it's seashells, flower petals, maybe the leaves that have a bright underside, for example. Certainly if there's any trash nearby, anything with bright colorations, males will pick up and they're going to decorate that bower. Now, from the male perspective, by spending this extra energy and by being able to accomplish this complicated behavior, that's going to increase the male's reproductive success. He's going to have a better chance of being chosen to mate with. So again, males that have that behavior are going to pass that behavior gene on to their offspring. So we'd expect that behavior to become more common in our population. From the female perspective, the females are evaluating the male's genetic quality based on this behavior. Maybe males that can do this behavior must be smart enough and healthy enough, and so that's going to indicate something about them being a good mate choice. And so here's an example of some bowerbirds in action. Here the male is kind of this shiny black. He's built his bower with the two sides. We can see the female inside, and you can see he's collected all these different colored items around that he's just now starting to decorate. And if he finishes up correctly, she's going to stay and they'll mate. So if we take a look at our sexual selection in females, we said because of their high cost of reproduction, they're going to have a strategy of being choosy. And so we would expect choosy behavior to become common in females, and certainly that's what we see in species where females have a very high reproductive cost. In males, where cost of reproduction is much lower, we're going to expect to see not choosy behavior, but the selection for specialized traits, whether it's large size and horns, if it's intrasexual selection, or whether it's bright colors and courtship behaviors if it's intersexual selection. And remember, that's where we started. We said it's the males of most of these species that have the unusual characteristic, and that's why we see these specialized traits in males. Now, our whole story here with sexual selection is that it's about cost of reproduction. And if that's really true, if cost of reproduction is behind this, what would we expect then if we had males that were spending lots of energy to reproduce and females that had to spend relatively little? It was cheap. So for example, what if we had a species where males had a high cost of reproduction and females had a low cost? Well, if cost of reproduction is really driving this force, we would really expect a role reversal. We would expect maybe males to develop choosy behavior and females to develop some sort of specialized trait to attract the males. Now, there aren't many species that have this setup where males spend more energy than females, but one such species are seahorses. Not all species of seahorses, but about 5 or 6 species. And in these seahorse species, that's exactly what we see is this role reversal. And what happens in these seahorses is the males will produce a little net that hangs off of their tail. Females will squirt their eggs in and swim off, and the female's kind of done with the whole business. The male will fertilize those eggs, and then when they hatch, the male will provide all the parental care. And so in those species of seahorses, we see that males are very choosy, and the females tend to develop these bright coloration patterns, these advertising traits, if you will, again, exactly like we would predict based on our cost of reproduction. Wrapping things up then with our sexual selection today, we know that sexual selection is going to be differential fitness due to success at acquiring a mate or kind of the competition of mating, and that we're going to see sexual dimorphism or different forms of males and females, and because of the fact that males and females are going to have different mating strategies, which are due to the different costs of reproduction in certain species. And again, these are not conscious decisions these organisms are making, but organisms that make these decisions or reproduce in these ways that we've described are going to have the highest fitness and pass those traits on to the next generation. And so we can have intrasexual selection where males compete with each other, or we might have intersexual selection where females are going to exhibit more of a mate choice. For example, in some species of fish, the female will squirt her eggs on the bottom of the stream and swim off. The male squirts his sperm on the pile of eggs and he swims off, and there's no parental care. So cost of reproduction is about the same. And so for those species, we don't expect to see sexual dimorphism. So for many species, males and females may look the same, at least from a distance, and that's going to be due to similar costs of reproduction.